We're going to analyze the rational function in example 8b from notes 4.1, days 2 and 3. And the first thing we're going to do when analyzing the rational function is we're going to factor the numerator and the denominator. So in this case, the numerator, we're first going to take out the greatest common factor, which is 3, leaving us with x squared minus 9. And the denominator, we can factor that trinomial as x minus 3 times x plus 1. Then we're going to look and make sure everything's factored completely. In the numerator, we have a difference of squares, which is x squared minus 9, which we can factor as x minus 3 times x plus 3. And in the denominator, we're going to have x minus 3 times x plus 1. And why don't we go ahead and get the simplified expression, because we may need that later. So the simplified expression or function is going to be 3 times the quantity x plus 3 over x plus 1, where x is not equal to 3. Okay, now we're going to go on and find each of the pieces of our analysis. We'll begin by finding the y-intercept. When finding the y-intercept, we'll let x equal 0, and we'll evaluate our function at 0. So f of 0 in this case is easier to find from the original function, not the factored form. And that's going to be negative 27 over negative 3, which is 9. So our y-intercept is the ordered pair 0, 9. Next, let's go ahead and find the x-intercept. To find an x-intercept, we're going to look for values where the numerator is 0, but the denominator is not equal to 0. In this case, we'll look at the factored form here, and we'll see that when x is 3, both the numerator and denominators are 0. So that's not going to be an x-intercept because it's not part of the domain. 3 is not part of the domain. So our only x-intercept is going to be the ordered pair negative 3, 0, and that is going to have odd multiplicity because the factor x plus 3 only occurs once in the numerator. Next, we're going to go find vertical asymptotes. Vertical asymptotes are values, we find them where the denominator is equal to 0, but the numerator is not equal to 0, or really the multiplicity of the 0 in the denominator is greater than that in the numerator. In this case, our only vertical asymptote is going to be at x equals negative 1, and that's going to have odd multiplicity. Positive 3 is a value that makes both the numerator and the denominator 0. The multiplicities are the same, so x equals 3 is not going to be a vertical asymptote. Next, we'll look for holes. When we're examining holes, we're looking for common factors in the numerator and the denominator. And really, we want factors that have a greater than or equal to multiplicity in the numerator as in the denominator. So here we're going to have a hole with an x value of 3 because x minus 3 is the common factor. To find the y value, we're going to have to use the simplified expression. Okay, so for the y value, we're going to substitute x equals 3 into simplified expression. Okay, and the simplified expression we'd already written up above is 3 over x plus 3 divided by x plus 1. So we substitute 3 in for x, so we're going to get 3 times 6 over 3 plus 1. So that's 18 over 4, which is 9/2. So we're going to have a hole at the ordered pair 3, 9/2. Next, we're going to talk about the infinite asymptotes. To find the infinite asymptotes, we're going to look for, we're going to examine the degree of the numerator and the degree of the denominator. Okay, so we'll do that analysis over here. So we're going to look for infinite asymptotes. Okay, that's describing n behavior. and we're mostly going to be interested in horizontal and slant asymptotes. For this rational function, the degree of the numerator is 2, and the degree of the denominator is 2. When the degree of the numerator equals the degree of the denominator, we have a horizontal asymptote with an equation equal to the ratio of the leading coefficients, which in this case is 3 over 1. So we have a horizontal asymptote at the line y equals 3. The last thing that we want to know in our analysis is, does the graph intersect the horizontal asymptote? Because remember, you can intersect a horizontal asymptote but never a vertical asymptote. So does f of x cross the horizontal asymptote? To determine that, we're going to let the original function, 3x squared minus 27 over x squared minus 2x minus 3, we're going to set that equal to the equation for the horizontal asymptote, which in this case is y equals 3, and then we're going to solve this. So we're going to multiply both sides of the equation by x squared minus 2x minus 3, which is going to give us 3x squared minus 6x minus 9. We can go ahead and subtract off these 3x squares. Those are going to cancel out, leaving us with negative 2x equals negative 6x minus 9, which is going to give us, oh, I'm sorry, that's a 27. Let's correct that. 3x squared minus 27, sorry about that. This is going to give us, when we add 9 to both sides, we're going to have 18 is equal to negative 6x, which is going to give us that x is equal to negative 3. So initially, it appears that our graph intersects the horizontal asymptote. However, x equals negative 3 is not part of the domain. Okay, so x equals negative 3 is not part of the domain. Remember, we have a it should be x equals 3. What went wrong? Oh, this is negative 18. So x equals positive 3, and positive 3 is not part of the domain. Sorry about that. Which means that the graph does not cross the horizontal asymptote. And that's our analysis.